Okay. I'm hoping it's recording, but I don't trust QuickTime anymore, and don't trust anything. Someone asked me how to send messages on here. Let me just switch my role to be a student. I know that somewhere on here there is a button that tells you or allows you to contact the course instructor. Now, this is supposedly the view as a student. This is what you're supposed to see. But I don't trust Sunderland at all because, like the test on Monday, I can view the system as a student, but when I try to write a test, for example, it went fine for me because I'm really the instructor. It allows me to write that test that you couldn't open on Monday because the date was wrong. So I can't see that kind of thing. It's invisible to me, even though it says this is showing me exactly what students see. Having said that, let's stop complaining and just look at participants. Jaco Geldenhuis. That's the only one I can see as a student. So I am going to guess that when you click on participants, if it's even visible, you'll also be able to see my name here. And if you click on it, you get my little picture, and you'll have a button to send a message to me. I don't, because I can't send a message to myself. Someone said that this is not working, but it actually is working for me. I can send a message here to myself. So let's just see if... But what you ought to see is, I'm just going to pick on a random person. I apologize, Abongile. What you ought to see is a little button like that below my name that allows you to send a message to me. In this case, I'm going to send a message to Abongile, but I'm not. Don't worry. Okay, fine. So I'm not going to message Abongile. Instead, I'm going to go back and read the page some more. So I don't know, yes, okay. Just try that. If it doesn't work, you can send a message to them, because it's important for you to be able to contact me. Okay, right. Let's look at something else. As PD Wi-Fi, how many Wi-Fi routers do we have? I think we only have one outside the door. I think the issue is the number of devices. So you all switch off your phones and everything will work. Now this is a stupid screen because you can't see this message clearly, but on a real computer screen, you'll be able to see that it says here, you do not have to implement multiplayer for the first submission. We're going to scrap the multiplayer mode. You won't get marks for it now, but we will get marks for it later on. Okay? So don't delete the code you've written, but you can submit it as is, but we won't be testing the multiplayer mode or give marks for it. We'll be testing all of the other requirements, but not multiplayer. The networking is still not apparently very stable. Right. Tomorrow you have to hand in the project by 2 o'clock. This is like browsing the internet in the 60s. No, that was before the internet existed. Let's zoom in. So tomorrow at 2 o'clock is the deadline for the project submission. If I click on this, can I submit as a diligent student? Yes. To create a zip file from the command line. Do that. Okay, fine. That's fine. And I should zip only the Java files. And you should upload that right there by clicking on Add Submission. So I'm not going to go through that. I'm just going to assume you know how to do that. And instead, we will carry on with what we have to do. So in some sense, we're catching up a little bit. We had a mentor session yesterday. I sent a message to everybody who didn't do brilliantly in the first test and asked them to come to Narga for the Tuesday tutorial, since most of us would have had no tutorial. And so I guess only about 1/3 showed up. But that's fine. If you send me a message, that's also fine. And if you're just not interested, that's also fine. I kind of want you to pass, but I don't mind. I'm not offended. we'll carry on with the mentor sessions and we'll kind of extend it to all students. This week we're not exactly coasting, but we're kind of taking a little bit of a rest. It's a difficult week for me. I've got 3 other courses that have projects due. But next week we start with recursion, and that's a big one. We'll spend the rest of the course, most of the rest of the course, just talking about recursion and how to use it. It's an important concept in computer science. Something we had a staff meeting just before this class, and something that came up is the idea that we are training students to be hackers. We want you to program, and program well, because it develops. We don't care about programming. I don't care about Java. But what I do care about is the ability to think in a certain way. To see a problem that says, read a file with the following format and calculate the following statistics about the file. And what I care about is you not fainting, but telling yourself, okay, this sounds difficult, but I can break it up in parts, and I can do it one step at a time, and I can solve it. That kind of computational thinking. I've got a difficult problem here. I mean, that was a trivial problem, but there are more difficult problems. How do I approach this problem? How do I break it up? How do I solve it with a Java in this case? But you'll have other tools. Next year you'll learn Python and C and assembly language and maybe some other language. And you'll have more tools to solve these kind of problems. And sometimes you don't need any programming language at all. Sometimes the command line is your best friend, because the command line is really powerful and you can do a lot on here. Okay. So, we want to learn to think. We don't want to just learn how to do this kind of stuff. We learn it at a tech, Polytechnic or Technicon or one of those places where you're basically just doing an apprenticeship. That's not strictly true, because the Technicon is more than that. But we're not training you. This is university, and we're trying to teach you how to think. In the future, next year and third year, computer science will have much more science to it, because you're doing a science degree, most of you, many of you, and we're teaching you to be scientists. So it's not all fun and games and programming. Having said that, I love programming. I do it every single day of my life. And I love science as well. Science is really exciting. I wonder if I have my Science is Exciting video on here. Do I? But I don't have a mic. I think the mic cable is dropped down. I'll show you my Science is Exciting video on Friday. I'll make them fix the mic. Science is exciting, and there are all these cool things you can discover that sometimes involve a little mathematics, but that you can do with programs and explore things, and not just adding arrays, but exciting things of the mind. Today we're supposed to talk about IFS and statistics. I cannot think of a more boring subject than statistics. When I was a second year, I took statistics, math stats 2. We were forced into this really cramped little room, and it was like 38, 39 degrees all the time. And we had this big man with big teeth teacher. He was oily, and we called him the big crocodile. And it was a really unpleasant experience, and I didn't do very well. I hate stats by association with this man. But this other stuff is amazingly fascinating. IFS, iterated fractal systems, is fantastic stuff. So what it is you have a small set of numbers, and they are coordinates of points. Actually, well, not exactly. They are transformations of points. So you start with a point somewhere, and you transform it according to this matrix, and you plot those points. And then you transform them again, and you plot those points, and again and again and again. And you wouldn't believe it, but a little picture will form. People have used this in reverse, to take a picture and compress it down to this kind of matrix that starts with just a little seed and transforms it into a whole picture. And the complexity of that matrix describes the details of the picture, and it's amazing stuff. So IFS is really fascinating stuff, and I hope, I haven't checked the page numbers, damn, I should make a note to myself, but I hope you read it because it's hours of fun. But instead, I want to do something similar, which is even more exciting, the best exciting thing in the world. So who of you have heard of fractals? Apart from me saying iterated fractal systems. Okay, who's heard of the Mandelbrot set? 5 people. Okay, let's pick a victim. Justin, Keegan, no, Thomas, Keegan. Who is it? Justin Keegan. Got to have the order right. Yes, that's what you said. Justin, what is the Mandelbrot set? Tristan. All the same. Justin, Tristan, what's the Mandelbrot set? You said you know. It's like this.
It's like a picture.
You don't know much about it.
You can zoom into it and then it regenerates and it can go on forever.
You can zoom in and it regenerates. Sounds alive. Okay. Anybody know anything more? Is that all you know? Yes, Craig.
Looks pretty cool.
Its perimeter size is theoretically infinite. It depends.
What?
The size of
I didn't hear that one word. Did you say theoretically infinite? What does that mean, that it's theoretically infinite?
it means that
Why is it not physically infinite?
it's a ruler small enough to measure its perimeter, then it would be infinite. But the problem is that its perimeter can only be defined by the size of the ruler.
You guys have not done second year calculus, or maybe you have. Now, I can't recall the mathematical theorem where you have an object with a finite volume but an infinite area. Have you done this? How much paint would you need to paint that object? Well, its surface is infinite, so you need an infinite amount of paint to cover it all. But its volume is finite. How is that possible? Amazing. Well, when the professor tells you that, just say, stop it. Stop it. You don't need an amount of paint to paint it, because the surface may be infinite. At some point, it gets so small that one drop of paint will cover the whole of the rest of the surface. I mean, when the area that you need to paint inside is less than an atom thick, you can't put paint in there. It's not stupid, it's exciting. There are many of these objects, and why are they called fractals? Well, we have one-dimensional objects like lines and rulers, roughly. We have two-dimensional objects like pieces of paper that I've brought to class here. We have three-dimensional objects, if I can find it, like boxes, and well, all of us are three-dimensional. But we also have objects that are 2.5-dimensional, somewhere between a flat piece of paper and a cubie, let's say. Or things that are 1.6-dimensional. It's somewhere between a flat piece and a straight line. How is this even possible? Oh, well, who knows? But I'm not going to go into the mathematics of fractals. But one important fractal is called the Mandelbrot set. Actually, that's not the fractal, but we'll skip over Tristan's lack of knowledge about that. So, the real fractal, I'll tell you, is called the Julia set. And it's a set of points, and it works exactly as I described a moment ago. You take one point, and you transform it in a very simple way, and it moves to a different point. And you do it again, and again, and again, and it keeps on moving. And then, at some point, it moves too far away from the origin. So I'm going to start at origin, transform, and I'm going to go outside a circle of unit radius. So outside radius 1, I'm going to stop, because I could go on forever. What I'm going to do is, for that point, I'm going to count how many jumps does it take to go outside the circle. It may be 1 jump, or it may be 10 jumps, or it may be infinity, because maybe I stay inside the circle forever. That point's Mandelbrot value will be the number of jumps. If I plot the original points, I get the Julia set. If I plot the number of jumps for each point, I get the Mandelbrot set. So I don't have a picture of it here, but I'm sure the internet will supply one immediately. Mandelbrot. Immediately, I said. Let's go there. Ooh! What is the name of that guy who made one song every day? John Never mind. He made a brilliant song about the Mandelbrot set. Okay, that's fine. I'll find it in a sec. I have it on this computer. I could, but you would be surprised. I know at least 20 songs about the Mandelbrot set, and yes, I have a playlist. Bookmark. Let's open the init key. This is just slow. I'm choosing Wikipedia because it has good pictures. So, but they're not loading. So it's not helping. Oh, there we go. Fine. So this is the Mandelbrot set, and you see it everywhere. And that's the big one. There's nothing outside it. The colors are the number of jumps. So black means infinite, and anything else means somewhere between 0 and infinite. Thanks. 0 and infinite, yes. That's the word I'm looking for. Okay. Right here at the edges, it's 0, because these points are so far from the origin that they're already outside the unit circle. But a point around here, I can zoom in. Oh, not much. Okay. A point around there takes a few jumps and then it goes outside. Now, just to be clear, it doesn't jump around on this level here. We take that point, and in a different place, we transform it and make it jump outside. We count how many jumps before it goes outside the circle, and then we come back to this drawing and plot the yellow here. It's not as if this point is jumping there and there and there. That's something that's maybe a little confusing. Okay, fine. So, oops, my mistake. So, let's just see. Let's just see that. So what we see here is people zooming in on the Mandelbrot set. Okay, it's almost done. It's almost done. Just a few more hours. Going in, deeper, and deeper, and deeper, and deeper. It's almost done. Just a few more. Almost done. Almost done. Yes. Okay. Let's just stop that. Okay. So. This is just a textual plot. Maybe we'll plot that today. Who knows? But how do you zoom in? That's what I wanted to show you. So, if we look at this picture, I only have so many coordinates. I only have so many pixels that I can plot. So, let's say this is from 0 to 1,000. So my x coordinates, let's say for this 0 line, let's say that's 0. My x coordinates can only go up in 0.001 steps. So I'm only plotting the point 001. I'll start with the point 0, I'll make it easier. Let's say the origin is right here, where my cursor is. That's 0. The next pixel is 0.001 or 0.0010. The next pixel is 0.002, 0.0030, 0.0040. So I'm only plotting certain points. But between 001 and 002, there are an infinity of points. So if I zoom my picture in so that this left-hand side isn't minus 500 and the right-hand side is plus 500, but instead this coordinate is 0.001 up to 0.002, then this center will now be 0.0015, which is right in the middle. And when I step, the next pixel, given that there are, let's say, 1,000, will be 0.0015001. And the next one will be 0.0015002, and so on. So I can take any bounds, any rectangle here, and plot only the points inside that rectangle. And then I'll see more details because I now have more pixels to plot. I have more coordinates to explore. Now you'd think that the difference between two pixels, one is 0.000001 and the other one is 0.000002, are insignificant. But that is not true. The whole idea of fractals is that they're non-linear, which means that if there's even a tiny, tiny little change in the inputs, the outputs may be vastly different. So I change the inputs by just a tiny amount, a millionth of a millionth, and the output is very different. The 1 point takes 5 jumps to go to the unit circle, outside unit circle, and the other point that's just slightly different stays inside the unit circle forever. So difference in the number of jumps, difference in the color. And it's that fractals part of it, the nonlinearity, that changes, that makes the Mandelbrot set so rich and interesting. The first time that people observed this was in the 1950s. I forget the guy's, I'm sorry, I didn't do the research, but I forget his name, but he was the first to investigate how do you predict the weather. And how people have always predicted the weather, it's very interesting, is they take the whole atmosphere and they divide it into blocks. So the atmosphere is just a thick ball of cake. And then they cut it into smaller cake cubes. And then they take 2 cubes that are next to each other and say, if the wind is blowing in this cube at a certain point, then just shortly afterwards, the wind is going to blow in this cube. And if there's rain in this cube, then there will be rain in the cube below it soon. So they have these equations called flow equations, where they describe how what happens in the surrounding cubes affect what's happening in this cube. And they run this a simulation, because these things are probabilistic. Just like our coin flipping that we did the one time. They run this over and over and over, and then they see, 99% of the time, it says that tomorrow's temperature will be 30. So I'm going to predict the temperature for tomorrow is 30. And 60% of the time, it says it's going to rain. So I'll say that the probability of rain for tomorrow is 60%. Did I say 60? Yes, must have. And this guy noticed that if you tweak the starting conditions of these cubes just a little bit, you get a vast difference. One system says it's going to snow, the other system says it's going to be a heat wave. So weather is non-linear. And the famous quote, I don't know why I'm telling you all this stuff, but educated people need to know this. This is part of when you go to a drinks party, you're fraternizing with your CEO boss at the bank, then you need to tell him, oh yes, the Mandelbrot set, of course. Frightfully old news. Okay. So this is the origin of the famous saying that if a butterfly flaps its wings in Brazil, it can cause a thunderstorm in Tokyo. I think that was the original quote. Just that small change in the atmosphere can have massive implications in other places, or at a later time. Okay. Coolio. So we want to do the Mandelbrot set. Wikipedia is going to tell us all about it. here we go. What do you what? Okay. So I'm going to start here with this equation, and it says that the next point z is simply the previous point z, but you square it and you add c. And the only tricky thing is that z and c are not numbers. They are complex numbers. Okay? So we have to learn how to use complex numbers, but that's pretty easy. I'm doing this in lieu of, my mistake. Sorry. I'm doing this in lieu of iterated fractal systems because even though there are fascinating stuff and related to this somehow, it takes much longer to explain that. But we have 15 minutes to implement Mandelbrot, and we'll do it immediately. So I'm going to start a new project, make it big, bigger the better. New Java project, Mandelbrot. Man, why don't I uninstall this stupid plugin? I never use it. Say again? The public class.
Remember to click the block.
Oh, to click it. Thank you very much. Oh, yeah. Okay, click. Happy now? Mandelbrot. Okay, excellent. So what I'm going to do is I'm going to start with a quick explanation of complex numbers. Complex numbers are really just two-dimensional numbers. They're like points. If I have a complex number C, it has two parts. One is called real and imaginary. Have you done complex numbers in maths? No. Did you do it in AP maths?
Yes.
Okay. Who did not do it? Okay, quick overview. Complex number has two parts called the real part and the imaginary part. This is R and I, they're just two real numbers. R is called the real part, I is called the imaginary part. It's imaginary because it's actually multiplied by the square root of -1. Don't think about it, okay? Right. So adding two complex numbers is easy. A plus B is simply the real part of A plus the real part of B and the imaginary part of A plus the imaginary part of B. Okay, addition, done. Multiplication, a little trickier. So, basically we're just going to multiply out. So, it's AI times BI, and that's equal to AR times BR plus AI times BI, comma, and the second part will be AR times BI plus BR AI. Now, I'm not saying what I'm typing, I'm sorry. Okay. And the only little tricky part is because I just mentioned -1, when you multiply AI and BI over here, that actually turns into a negative number because you're multiplying two square roots of -1. And yes?
Sorry, would it be possible to zoom in slightly?
Yes, it will be possible to zoom in slightly. Any other questions? No, I don't mind. Any other questions? Okay, right. So let's just go. Maybe a little too much because you can't see the end of that. There we go. And one more thing, I'll just put a comment around here so we get rid of all those ugly red lines. Okay, there we go. Now we have orange lines because I did typos, so never mind that. Okay. So only other fix I have to make is that these are two real numbers, and the way I'm going to handle them, they'll all be real numbers. But AI times BI is a real number, but I have to change the sign because there's a square root of -1. Too complex. Much easier to just remember the rules, which says that if I multiply two complex numbers, then that's the product. Okay. So I'm just going to write Mandelbrot. Maybe I need a victim. What's your name? Reese. Where do I start? Well, what would you do? Exam time, question 1. Write an implementation of Mandelbrot. What? Right click. Oh. I would say we want to plot it. So I'm going to say for x equals some value, I'll just say 0, and up to some value, let's make it 4, x, and make it step in 0.1, 0.01. Okay? So my x coordinate is going to step like this, and my y coordinates are going to step like similarly. Okay, and now I'm just going to plot a pixel. Only issue is that, what do I plot? No, I don't plot anything. I have to plot the color of this pixel, and the color is a function. I mean, it depends on how many steps before I get out of the circle. Do you agree, Reese? Did you have AP Maths at school? Thank you very much. Okay. So I need to calculate the number of jumps. It is a formula, but what I really want Reese to say, don't tell him, is that we should use a function. So I'm going to say plot, which I know doesn't exist, Mandel of x and y. And then I'm going to write a little function, public static int, because it's going to count the number of jumps. And it's going to take a starting x and a starting y. Now, I didn't make this perfectly clear, but the bottom line is that that x and that y, that coordinate, I'm going to treat that as a complex number. And I know that Mandelbrot says while xy is in circle, z, the next z, is the previous z times z squared plus some c. Okay. Not too difficult yet. So x and y is in the circle. Reese, how do I check that? Yeah, how do I check that some coordinates in the circle?
You check that it doesn't exceed the radius from the origin.
Okay, so the distance from the point to the origin should not be more than the radius. Okay, so what is the distance from x, y to the origin? Well, distance equals math.square root of the x difference squared plus the y difference squared. And it's the dx in this case is the difference between x and the origin, so x minus 0, so that will just be x, and the same for y. Oh, man. So that's the distance from xy to the origin. I don't need to take the square root. I mean, if the square root is less than 1, let's say that's my radius, then the square will also be less than 1. So I don't even need the square root. I can just say if that number, that's the distance, is squared, if that's less than 1, I'm still inside the circle. So while this is less than 1, I'm inside the circle. And I'm going to calculate the next point. Okay, so let's write this out. C is a complex number, so it is C, R, and Ci. And Z is my current point, so that must be xy times xy. And this is my new point. Now, I could call this x, but just trust me, it'll cause confusion. So instead, I'm going to call it new x and new y. We could go the long route and actually try it, and we'll see there's an issue. What's the problem, Reese? Okay, just resting your arm. Fine. That's no problems. Okay, good. And I've got to remember that this is complex multiplication. This isn't just real multiplication. So I need my little formula from down here, which says that these two numbers, if they're complex, their product is really x times x minus y times y, comma, xy plus yx. I've just substituted those numbers into this little formula down here. Okay? And I can add two complex numbers. So that's x squared plus minus y squared plus cr. And this is just 2 times xy plus ci. But Java doesn't understand complex numbers. So I have to break it up into the separate x's and the separate y's. Now this is the trickiest part, I think. Well, will it work? Nx is x times x minus y times y plus cr. Ny equals 2 times xy plus ci. Can I just break it up like that? Well, I can. I mean, there's no issue here. But if I didn't have double nx and double ny, this would have been where my program breaks. Because if I'd written x becomes that story. Look, now I'm using the old x down here, the old x. But if I already update x there, then I'm actually using the new x in the next line. So in some sense, I must keep the old x around, which is why I introduced these variables nx and ny. And it won't help doing it the other way around. I can't say, well, let's update y first, and then we'll do x. Because now I'm using the new y, whereas I actually want to use the old y. Okay. So I'm putting that back. And this seems silly, but at the end I'm just going to say x is the new x, y is the new y. I'm going to make these constants. I'm going to say public static final int ci equals 0.4. Doesn't matter so much. Okay. I'm still not done. I want to count the number of jumps. So I say I start off. Sorry. Thank you. Almost done. Okay. I start off with 0 jumps. It's taking 0 jumps to get out of here. And now I'm going to say jumps plus plus. And right at the end, I'm going to say return the number of jumps. Reese, are you happy? Yes, you say that, but you didn't even look. You were looking down at your phone and I know you're looking at your manicure. And stop agreeing so much. Okay, who sits in front of you? Just tap them on the shoulder. They automatically say their name when you tap them. Look at this. Matt. Sup, yes. Sup here. What's your name? Josie. Are you happy? Josie is having issues with her own feelings. She's have difficulty processing them. I know it's overwhelming. I also cried the first time I saw this. Okay. Josie, there's a serious issue here that I've not addressed. Can you make a wild guess at what it is? I know there's an infinity of possibilities of what it could be. I know the answers you could give are limitless. I know there's a very large number of things you could say now. And that's one of them. Okay, right. So what Josie has spotted, but is too shy to admit, is that we have not handle the case where it stays inside the circle forever. So this while loop never terminates because it stays just staying inside the circle, going in a circle or just staying at 0, who knows. So we have to stop this while loop at some point. We have to decide how many jumps are we going to tolerate before we call it infinity.
Why it's theoretical and like not in practice. Because
What do I-
in practice, if it's infinite, there is no like, oh, we've had enough now. It's probably infinite. That shouldn't work like that.
Well,
Which I now know when you say that's theoretically infinite, you're like, oh.
no, Craig was talking about something else. Craig was talking about the fact that how do you... well, I know Craig very well. And that's not what he meant. I knew him since he was an infant, yes. And when Craig says that kind of stuff, he means that something entirely different. Now, it's kind of theoretical. We're breaking something, but for our purposes, it'll be enough. And if we find it's not enough, we just tack on a 0 to the number of jumps we allow. I don't care. One keystroke and we can fix our issues. So while we are still inside the circle and jumps is less than 100. Oh, no. Infinity. And I'll define infinity up here. And t should be 100. Okay. I can just change it later if I feel like it. Okay. So Mandel takes an xy coordinate, which it thinks of as a complex point, a complex number, and then it has a while loop where it repeatedly puts the complex number in the formula, Mandelbrot's formula, which says square it and add c, square it and add c, square it and add c. And while this number, or point as we can think of it, stays inside the unit circle, I keep on going, I count how many times I have to keep on going, and as soon as it jumps outside the circle, I stop the while loop, because it's no longer inside the circle, and I return the number of jumps it could do. And I have to take care of the fact that it may be infinite. Okay, so now I have a value that I can plot down here. And I'm out of time, but I should have used standard draw. I'll go back to my office and fix this and put it on the web. I'm a little behind with the web stuff. I know I owe a lot of you messages. I haven't seen the forum, but it's crunch time for many, many courses. And we'll all survive. Do you have any questions you want to ask me? This is fascinating stuff. Yes, ask me anything. About the test you wrote on Monday. Well, firstly, there was the fact that you started late. I'm really sorry about that. But we all complain about Sunlearn. It's difficult for me to navigate it. I can't make excuses. Secondly, there is some kind of glitch where some people saw an old version of the question and some people saw a new version of the question, the same question. It showed some people one version and other people the other, and it wasn't planned. So in some way, I probably made a mistake, but I don't know how on earth it's possible. Some people saw an old version of the question, and therefore they couldn't give the right answer. The question was different. I'll fix that. I haven't done it yet. I'll fix it so that if you gave the correct marks, correct answers for the old version, you get the marks. And if you give the correct answers for the new version, you also get the marks. So I'll make it so that both answers, the old and the new, are both accepted. The only glitch is that in the old version, it was a little confusing because that A label was actually printed twice. So in the new version, it was only printed once, and you only had to give one answer. In the old version, there were two printings of A, and you could have given either. And either will be correct. Either the first or the second. Yes? There's a problem. Nothing will be printed because there's a problem in the program. And that's fine. I'll take that as correct. In fact, I didn't even work out the answers for the old version because when I saw it printed A twice, I changed it so that I only printed it once. And then I calculated the answers. And if there are no answers for the old version, I'll take any answer. Because I can't rely that you could have figured that, on the fact that you could figure that out. Okay. Sometime this week, the marks for the test will be done, but probably not before Friday, because tomorrow we have to mark your submissions. Project is due. Reese is still unhappy, or no, I cannot. I physically cannot. My hand is, see, you didn't notice this, but my one hand is clawed. I write with my left hand, but just uncomfortableness makes me impossible to write. No, please do not send me any emails. Just send me a message on Sunlearn, as I showed at the start. Except for that one student who won't work, but just contact me on Sunlearn. I do read those messages, but I'm just a little behind on them. Okay. What do you want? Contact ISIS. What? Class reps. Why? Oh, yes. What Frivaldo is saying, that you can try to contact him as well, and he'll get the message to me. I know it's kind of old-fashioned, but just pass the note to Rivaldo, and he'll pass the note to me. Okay. Thanks, guys. You have to go. You've got another class coming.